Hi, this is my second hat. It's in honor of my Scandinavian heritage. This Viking hat was given to us by my mother. She emigrated from Sweden when she was in her 20s and has been in the US ever since. Let's go over the answers to the worksheet on chapter 13. This key is posted on Educat already, but I just wanted to go over a few things with you. The first one asks you to come up with the name of the oligosaccharide that's depicted by the colored shapes. So to help us, I wrote in the name of each monosaccharide depicted, and all I want you to do is be able to write this out in a row with the full name. So fructose instead of FRC, mannose instead of MAN, and so on. So it's going to be in a straight line. The ribose is up here instead of right here because I couldn't fit it. But the important thing is there's a branch point here, which is this, and you would draw a vertical line down to show the one that's the branch point, or like you'll have to do on the test since you won't be able to draw, is write it all out, and then the one that's the branch point, put it in brackets right after the glucose or whatever it's attached to. So the brackets mean it's a branch point at the thing right ahead of it. So that's how you can write it on a test answer. The next one is, and one other thing, where did I find the information for these? It's that key that I had linked in the slides. So if you go to that website, it has the symbols and names for all the different monosaccharides. So you want to have this handy when you take your exam next week. You can either print it out like I did, or you can just have it up on your phone or something. Find the appropriate symbol, and then if you click on the 3-letter code, it'll tell you what the name is. Okay, number 2, you have to determine which of these pictures matches which name. So let's just go one at a time. This one is 2 monosaccharide rings. Looks pretty similar to stuff we've seen before. The key thing is the carboxyl. So a carboxyl or a sulfate are both negatively charged, and that's the key structural feature of a glycosaminoglycan. Well, they also have an amino group. That's why they're called aminoglycans. But the key thing is they have a negatively charged group on the molecule. So this would be a glycosaminoglycan, or B. And then the other ones we have that are common are shown here, and they have sulfate groups in addition to carboxyl sometimes. So again, sulfate's negatively charged, a carboxyl very negatively charged sulfate, and then this one has 3 sulfates and a carboxyl. So a lot of negative charge is a glycosaminoglycan. The second structure here has alpha 1,4 linkages, alpha 1,6 linkages. It's all glucose rings that have no substitutions. So that structure represents starch or glycogen. Glycogen is not a choice, so the answer is starch. No substitutions, just straight glucose rings. This one has glucose type rings, but also every ring is an N-acetyl group. So what that means is there's a lot of nitrogen, a lot of acetyl groups, and that is a hallmark on every single ring of chitin. So chitin is the main carbohydrate in insect exoskeletons and crustacean shells. And then finally, the last one is the one that's not chosen, which would be glycoprotein. So process of elimination. But the reason you could figure that out is it actually has the word protein in it. So here's the core protein, and then the carbohydrate structures are here. So glyco means carbohydrate, and it's got to have a protein, so that's a glycoprotein. Question 3 is on the next page, and again, we have to match some things with carbohydrate structure, but there are no pictures. This is phrases. So it could be part of an N-linked glycoprotein. What that means is the protein is linking through an asparagine for the N-linked. So N-linked means asparagine on the protein. So typically, a nitrogen on the carbohydrate makes that linkage easier to do. And if you remember from the previous picture, starch did not have a nitrogen, but chitin did. So the answer is chitin. Glycogen and starch are very similar in terms of the carbohydrate part. Cellulose looks a lot like chitin, except for it doesn't have the N-acetyl groups, so that's not it. And then raffinose is a small oligosaccharide that is found in vegetables. That's here, raffinose, and you can see that there is no nitrogen. It's a galactose, a glucose, and a fructose, and there are no substitutions, just carbohydrate, normal with hydroxyls. So that's one. B, alpha-1,6 and alpha-1,4 glycosidic linkages. We saw that on the previous question. That represents starch, but it also represents glycogen. So how do we choose? It's this part. Also contains protein. So glycogen contains glycogenin protein as the core. So that's the main difference. It's not the only difference, but it's one of the main structural differences between starch and glycogen. Glycogen actually has a glycogenin protein core. So that's B is number 3. And then finally, they're all biodegradable. So the key things are water resistant for spy footwear. So water resistant is going to be chitin and cellulose. They both have beta linkages, glycosidic linkages, which means their hydrogen bonding is so strong they don't dissolve in water. So that would be water resistant. And then the spy part, I was trying to get you to think about which one would be most quiet. So if this is found in the exoskeletons of insects and crustaceans, it's the crunchy part of the animal. It's not going to be as quiet as cellulose, which is found in bark, wood, and grass. Much more flexible material. So the best answer for that one is number 4, cellulose.